Module 1, Coding and Programming Skills. Lesson 6, Programming Paradigms. Until this point of the course, the basis of programming and the characteristics of programming languages have been presented. Nevertheless, there are also programming philosophies and programming paradigms that explain how the program implementation is structured and conceptualized. Programming paradigms can be described in the literature as a classification criteria of programming languages. Nevertheless, it is not completely correct as several programming languages allow more than one programming paradigms. Imperative versus declarative programming paradigms. The two main programming paradigms that describe most of the programming languages are the imperative and the declarative programming paradigms. The main difference among them is the control of the order in which the operations or instructions are executed. In imperative programming paradigms, this order is stated in the implementation of the program, while in declarative paradigms, the order in which the operations should be executed is not provided. On the one hand, some programming paradigms that can be included into the imperative paradigm are procedural paradigm, which implements a computer program as procedures that call one each other. Object-oriented paradigm is based in the concept of objects, which are elements that contain data and code. On the other hand, there are some paradigms that can be included into the declarative paradigm. Functional paradigm, where the desired result is declared as the value of several function evaluations. Logic paradigm is associated to languages that build programs as a set of sentences in logical form. Reactive paradigm, which is related with data streams and the propagation of change. Parallel computing is characterized by carrying out several calculations or processes simultaneously, exploiting the computer architecture considering that most of the computers have multi-core processors. Several processors in the CPU could have a GPU, graphic processing units, or more complex big data architectures. When performing parallel computing, there are two paradigms that could be complementary. Task parallelism, which takes advantage of the independence among the tasks of a program, executing each task in different processes or threads at the same time. Data parallelism. In this parallelism, data is divided into several subsets, and each subset is processed by different processing units. Task and data parallelism paradigms are complementary. For example, when solving big data problems, distributed architectures are employed, and each subset of data is processes in different processing units, where task parallelism is also implemented when possible to reduce the processing time and optimize the resources usage.